Chapter 12 Gravitation 萬有引力。Okay, in the first section, gravitational force 萬有引力。Okay, what is this? Actually, this one is discovered by Newton. So this one is also one of the Newton's law. What happened? You should know that this story about the apple is falling to the ground, and then, but why? Up to now, you should know that for the Earth, we have the force acting on the apple, and then this apple will fall down with acceleration. Similarly, for the moon also have a force acting on it provided by the Earth. And check it, but is it similar to an apple? Put it down to the ground of the Earth. Of course, the answer is not. But why? In this chapter, we will focus on it. This one, Isaac Newton. Both are caused by the same kind of force, gravitational force. Remember it. Other than this force, we also have the other force. We may learn it later. For example, electric force, 電力, magnetic force, 磁力, like that. Now, go back to here. Gravitational force. What is it? For example, in this case, the symbol of is Fg. G stands for gravity. This one is universal. Universal means that even this one, we can do the experiment in the Earth, but actually we can do the same experiment in the other planet. Even you go to the other planet, we also have the gravity. Now, of course, this gravity should not be produced by the Earth, should be produced by this planet. But never mind, this force is universal. Everybody exerts force on any other object, including me and you. I can provide gravitational force. You also can provide gravitational force. But of course, compared with the Earth, our force are very, very little compared with the Earth. And the other one is the mutual. Mutual, 互相. This one means that I can attract you, you can attract me. So here, this one, the force between any two objects must have same magnitude, equal magnitude. For example, I provide 3 Newton attractive force. This 3 Newton attractive force will be exerted on you. At the same time, you will feel that 4 Newton attractive force. Okay, but of course, the direction of them should be opposite. In this case, you can see that equal in magnitude, opposite in direction, acting on 2 objects. It means that 2 bodies. Then this one is also action and motion pair. But this one is a special one, attractive only. It means that I can attract you, you can attract me, but I cannot produce any force to repel you. Okay, because for the gravitational force must be attractive force. So when you look at this diagram, you can see that for every object, okay, every object will have gravitational force. Okay, this force will be exerted on the other object around it. So in Chinese, 萬有引力，萬物都有引力嘅。How about the equation discovered by Newton? Will be this law of universal gravitation. This one, how to produce gravity? You must have mass. Here depends on 2 mass. These 2 masses, between them will have attractive force. So the attractive force in it should be depends on the mass of each of them. And also the other factor to affect it will be the separation between these two objects. Of course, because this one is the fattest, linked up to the force in between it will be a constant. In mathematics, this one we will say that proportional constant. In it, Newton found that the value of it is very small, will be 10 to the power negative 11. Of course, you need not to remember it, you just need to know it, what is this? Very small force. Very small value in it. So, because this one very small, then it means that these two mass, okay, the product of them should be quite large. Otherwise, you cannot feel the existence of this force. Okay. Now try to use this formula. This formula, of course, you need not to remember it. You can find it out from the formula sheet. Look at this. Greater in distance, greater in separation between two objects, then the force will be smaller. And here, drop very quickly because the square, okay, with increasing arrow. Then look at this diagram. If this initially the separation between them is r, if I increase the separation to 2r, then you can see that the force is not half of it, will be a quarter of it. And then this one 3 times, then should be 3 times, but we make it square. It means that 1/9. Finally, link up them together is not a straight line, should be a curve, like that. This curve should be, in mathematics, should be this one, 1/r square. And also, this one we will say that inverse square law. How about this? If we keep the same separation r, but we change the mass of them. Here, we think that one of them keep it the same. For example, this one keep it m, but the other one greater and greater in mass. Then what will happen? The force between them will be greater, depends on the mass of it, proportional. Here, the law of universal gravitation can be applied to the uniform spheres with all. So it means that if this one is a ball, we can apply it. Even this formula true for a point mass. In this case, we will think that this one, the concept of it is exactly the same as CG. For CG, we have a object like that. We can think that all the mass can be concentrated at CG to represent the whole thing. Here, the same. We can think that the whole object, this ball, all the mass can concentrate at the center of it to represent the whole object. Then it means that this formula can be true for this case. Not only 2-point charges, we can say that these two balls can have the same amount of force, okay, acting between them. And also, how to measure the separation between them should be the separation between their centers. Here, question. From the law of universal gravitation, the Earth and Apple attract each other, okay? Because other than this part, you will think that Apple is attracted by the Earth. Okay, I think all of you should know it. The apple should be attracted by the Earth. But if someone say that the Earth is attracted by an apple, you may think that wrong. But up to now, in physics, this one should be correct. Because between them, we have the gravitational force. You can attract me, you can attract me, I can attract you. Okay? We have the same amount of the force between us. So look at this. The apple finds towards the Earth. Okay, like that, you should know that this one must be correct. But how about the Earth? The Earth does not find towards the apple. Is it true? Okay, of course yes. But look at this. The answer is this, because the force acting between them should be the same. Objects of smaller masses accelerate faster. Larger masses accelerate slower. Actually here, initially this one is the apple, this one may be the Earth, initially like that. Finally what will happen will be this one. This Earth seems to be low motion, no movement. All the movement should be focused on the apple. It seems to be, but actually the center of mass of the Earth should be moved up a little bit, very very small, compared with the displacement of the apple. Okay, this one actually is coming from the momentum. In the last chapter, you should know it. This one, greater in mass, greater in inertia, but between them should provide the same force. Okay, between them should be the gravitational force, should be the same in magnitude, opposite in direction, acting on different bodies. Okay, because they have the same force but different in mass, then in this case accelerate. Okay, the acceleration will be very small. Finally, the displacement will be very very small. You can notice it, and you cannot notice this. Okay, after the calculation, you can find that A should be near to this value, 10. The actual value should be 9.81. But how about the acceleration of the Earth? Will be very very small. Second question, from the law of universal gravitation, a book and your body attract each other. Okay, this one, is it correct? Of course yes. Okay, but here the book does not find towards you. Okay, and also your body does not find towards the book. But why? Actually, from the law of universal gravitation, this one is the book, this one your body. Between them, we should have attractive force. But now, I cannot attract the book cannot attract my body. How to explain it? Should be this. Because in between it, we have the force, but this force will be very very small compared with the gravitational force. Then it means that we cannot observe this one. Okay, because use the comparison that you can find that this one is very very small. You cannot compare it. The force, how much is it? Should be this. Okay, very small compared with the weight of the book. Okay, try to look at example 1, gravitational force. Remember it in this chapter, just only focus on the use of the formula. The same, okay, just only substitute it. Find out the suitable value and then substitute it into formula, and then you can get the result. Look at this. Mass of the Earth given to you. Radius of the Earth is given to you, like that. Part A. Find the gravitational force between Amy and Bob. Go back to this. Find out the value. Here, you can see that the masses of them are 50 and 60. How about the separation between them? Should be 1 meter. Do you know that? What's the value of capital letter G? You can find it out. Substitution only. Okay, this. Remember it. This one is the force. The unit of this force should be Newton. Part B. Find the gravitational force between Amy and the Earth. Amy and the Earth. Then what should you do? This one. You should put the mass of Amy and also the mass of the Earth. And also find out the separation between them. This separation should be the radius of the Earth. substitute it should be 491. Actually, this 491, what is it? Should be mg. Okay. This one explain it why. We can find that g is near to 10 or 9.81. How to get it? At the back end, coming from law of gravity. Okay, part B, circular motion under gravity. Part A introduce the formula of universal gravitational force. And in part B, we will focus on the application, especially for the movement of the planet. And look at this. Due to gravitational force, an apple initially at rest fall vertically towards the Earth. Okay, you should know that this are free falling. An apple project an angle fall in a parabolic path towards the Earth. This one is the projectile motion. How does the moon orbiting okay around the Earth 圍月球圍住地球轉 force towards the Earth? Can you see that the moon is falling towards the Earth? I think all of you should think that this one must be incorrect, because you can see that the moon stay at the mid-air, okay, in the sky. You can't see any falling. You see? Now try to look at this diagram to explain what happened here. If the moon does not experience a pull of gravity, then what will happen? Exactly the same as the last topic, chapter 11, circular motion. Without any tension acting on the metal ball has its inertia. It tends to move in a straight line, go straight, okay, because the first law keep it in initial state. Then what will happen? This ball will move tangential direction, okay. But now, if like that, if the moon does not have any pulling force from the Earth, then what will happen for the moon? Moon will move along a straight line. This direction we will say that tangential direction. But of course, you will think that this one must be wrong, because you can see that the moon in the sky. Then what should you do? You should try to find out some force acting on the moon to pull it back to the circular path. What is this here? Experience a sideway pull of gravity. A sideway should be this, okay. Keep the moon moving around a circular orbit. Then in the last topic, you should know that without any force, this object should move in a straight line in tangential direction. But now we have the sideway attractive force to pull it towards the center of the path of the circle. Then this motion we will call it circular motion. How about this force? We will say that centripetal force, 向心力. So this one explains it why. Here, the centripetal force is required, okay, to keep the moon to move in a circular orbit. Then, once again, we cannot find out any centripetal force. Centripetal force just only the resultant force of the whole motion. You should try to find out the real force acting on the moon, okay, and then make it moving in circular motion. What is this? Of course, should be this one, pull of gravity. As a result, when you look at this diagram, you can see that initially the moon wants to move in a straight line in tangential direction. At the same time, the Earth gives it an attractive force towards the center. Then finally, it will change the direction, for example to this, And then once again, the moon wants to move in this direction, but it can't because we have the other pulling force, the gravity, to pull it back to the original circular orbit, like that. Finally, it will keep the same orbit forever. Other than the moon, we also have the other artificial thing on the circular orbit around the Earth. This one will be the satellite, 人造衛星, move around it. We will do the calculation to calculate the velocity of the satellite, and also of course the separation between it from the center of the Earth. Do the calculation, then we can find that the speed of the satellites, too high or too small, will not be the same circular orbit. You should try to do it. Try to find out the suitable value for it. How to do it? Of course, using the formula. In this chapter, we know that this one, gravitational force. In the last chapter, this force should be the required centripetal force. In this case, we will use v squared over r, because this satellite can control the velocity, the speed of it, 主導，所以就用呢條式。Combine them, you can find that this velocity can be calculated from this value. Depends on the mass of the Earth, this constant, and also the separation of it. Then you can notice that V does not depend on mass. This one explains it that the artificial satellites can be quite large, larger than it, but they can keep the same orbit. Okay, but how to do it? Same speed, then they will have the same orbit. What is this? Greater than the artificial satellites. This one may be the space station, 太空站, very large compared with it. Okay, but they can have the same orbit. But how? Keep it the same speed. Okay. Okay, example 2. Here, we have many different types of satellites in the sky, okay, around us. One of them is a very special one, geo. Geo means that related to the geography. Stationary, it means that keep the same position. Satellites. In Chinese, 對地靜止衛星. 對地靜止衛星. What is the meaning here? To tell us that what is it? Is an artificial satellite that always remains at the same spot. Same spot, it means that this. Here, for example, a loon, 12 loon. Then you can see that the satellite here. And then, for example, because you know that the Earth is moving around, okay, and moving it one round, okay, one revolution, it will spend 24 hours. For example, this one, 3 p.m. Then what will happen? The Earth will rotate like that. Okay, rotate to here. The time may be 3 p.m. And how about the satellite? The satellite will move to here. Also spend 3 hours to here. Okay, then what you do? You stand here, you can see this satellite. After 3 hours, it means at 3 p.m. you also can see the same satellite, exactly the same, similar to the moon. Of course, the moon is not like that, similar it only. But this satellite is very quite strange. When you look at it in the sky, you can see it. But what do you feel? You will feel that this satellite haven't any movement, because it keep the same position all the day. Even go to 6 p.m. you will go to here. How about the satellite? You're here. You also can look at it. Okay. What is the function of this satellite, and also how to predict what is it? Will be this. You can see that the orbital period. And once again, what's the meaning of period? The time for it to move around one cycle, one complete cycle. This one should be the same as the period of the Earth rotation. This one should be 1 day. Okay. Then this one directly over the equator. When you draw an Earth, this one equator, then this type of the satellite should be on the equator. And this one tells us that other than the equator, we also have the other satellites, maybe above the equator or below the equator. They also can move around it, but they cannot have the same period of the Earth's rotation. Then it means that they cannot be geostationary satellites. Now try to find out what will happen. We want to find out the angular speed of the orbital satellites. This question tells you that the period T already. This one should be 1 day. And then you can starting from it and then find out omega angular speed. Based on the equation, this one omega should be 2 pi over T. T should be the total number of the second for it to have one revolution. Okay? So after the calculation, for this value seems to be quite small. Part B. Find the height of the satellite above the Earth's surface. Of course, apply the formula and also the circular motion. Because in this, we know that the omega, this one 被動洗衣機 okay 洗衣機情況 so you can see that mm will be cancel each other, and then after the calculation we can find that should be g constant, m actually is a constant mass of the Earth, omega in part A you know it, then you can find out what's r should be this. Okay, 4.2 like that. Here, the height of the satellite above the Earth's surface. What's the radius of the Earth should be this. This one will be the actual separation between the satellite and the center of the Earth. Do the calculation, you can see that this. Okay. Is it too far away? Try to look at this. This one is 10 to the power 6. This one is 7. If I want to make it change to 10 to the power 6, then this one should be 42.23. Then you can see that R is around 7 radius of the Earth. Okay, so if like that, it means that this diagram should be wrong. The correct one should be like this. This one is R. Where is the satellite? Is around 7 times. 1, 2, 3, 4, 5, 6, and 7 here. The satellite should be here. Can you notice this? Okay. Actually, when you if you are take a UFO or the other spaceship, okay, far away from the Earth, you can take this photo. Okay, this satellite is quite small compared with the size of the Earth, but whereas it should be around 7 times of the radius of the Earth, will be like that. Okay, far away. Okay, look at this. If the satellite has orbital period is only 12 hours, not 24 hours, this one will be higher or lower. Of course, do the calculation. How to do it? Go back to this one. Go back to this. What is here? R03 should be Gm over omega square. What is omega? Should be 2 pi over T. Then square, it means that 4 pi square T square. Over it. Okay, over it means that you should inverse it. Then this one should be 4 pi square. This one should be T square. This one, constant no change, mass no change, pi no change. Here, the bracket is a constant. Then you can see that period is less because originally should be 24 hours, now down to only 12 hours. Then it means that the whole thing will be less than before. R should be smaller than before. Final answer, lower. Okay? Because this formula is very useful in this topic. Tell us that the period and also the position of. Okay. This one helps us to find out the new planet. Okay, in solar system. I will mention it later. But how to prove it? I proved it already. Okay, this one, mass of the sun. Actually, maybe in your primary school, you may ask that how to know that the mass of the Earth, mass of the sun, mass of the moon. How about mass of your body? Mass of your body, very simple. You just only stand on the balance, then you can find out the answer. How about the mass of the sun? Okay, how to do it? Of course, we cannot put it like this. This one is the sun, and then put the sun on the balance. Then watch the reading. Take the reading. You can know that the mass of the sun. Of course, this one impossible. Okay, but how about mass of the Earth? Is it simple? The same. This one is the Earth. Put it on the balance. You can find it out. Okay, and try. Okay, look at this. Firstly, you should try to find out the separation between Earth and the sun. And also, we know that the period for the Earth to move around the sun, one cycle should be 1 year. Okay? Try to do it. Find the orbital speed of the Earth. Here, this one, 2 pi r circumference over the total time. This one should be the linear speed. Okay, do the calculation very fast. Within 1 second, this one is 10 kilometers. Okay, for the Earth moving very fast. Here, how to estimate the mass of the sun? Of course, use the gravitational force and circular motion. Here, we notice that this one is mass of the sun, mass of the Earth, mass of the Earth, speed of the Earth, separation between sun, Earth, separation. Actually, everything you know it. Only one of it you don't know is the mass of the sun. You can use this one to find out very large. Okay. Okay, example 4. Stop here. Okay, here. Chapter 1. Okay, but before I do the chapter 1, you can look at your textbook and which one are parent weightless. Okay, in tutorial I will focus on it. Okay, tells you that what is the weightlessness, and also the other cannonball and is the other enrichment. I will mention it in tutorial. But before the chapter 1, I want to ask you this question: how to measure the mass of the Earth? How about this? Can we do it like that? What is it here? I put the Earth here on the balance. Could you tell me what is the reading of this balance? This one is the Earth. Okay, what is it? Okay, next tutorial I will ask you this question. Okay, try to find out what is this reading. Okay, on the reading of the balance, what is the reading? Okay, I want to ask you, tell me later. Okay, chapter 1. Here, true false question. The gravitational force exerted on an apple by the Earth is larger than that exerted on the Earth by the apple. You can see that this one accelerates the same as action and motion pair. Then you can see that larger is wrong, should be the same. Okay, action and motion pair. Part B, an apple and the moon would have the same orbital period if they were orbiting in the same circular orbit. Orbiting in the same circular orbit, it means that the same hour. Yes. Okay, the period of the circular orbit does not depend on the mass. Okay, I have mentioned that satellites and space station, they are not the same in mass, but they can have the same circular orbit because they have the same linear speed. Part C, if an object is at a height h from the Earth's surface, pay attention, especially in examination, this one, h from the Earth's surface. This h is not r. Okay, pay attention, h is not r. R should be h plus radius of the Earth. Okay, pay attention on it. This one, doubling the height will cause the gravitational force acting on the object by the Earth drop to 1/4, a quarter of it. It means that this one, from this to new r should be double the height. It means that 2h plus r. You can see that this r and this r is not double, so this one is wrong. Okay, pay attention this. Okay, second question. Assume that the Earth revolutes around the Sun. It means that move around the Sun in a circular orbit, and then giving you this radius. Find the gravitational force between the Earth and the Sun. Should be this answer. How to do it? Of course, write down the formula. Okay, but here I haven't give you the formula. This one very easy, just only substitution. Here, force should be, look at here, the force between Earth and Sun. So between Earth and Sun, you can get the value of G. What is the mass? We have two mass. One is Sun. Okay, Sun. The other one should be Earth. What is the separation between them? Is this. Substitute everything, you can get this answer. Level 2 question. Okay, that's all for this chapter 2.